The vibrant energy and sharp mind you enjoyed in your younger years can feel like a distant memory after 60. What if the key to restoring that vitality isn't a complex medical intervention, but a subtle shift in your body's internal network? We're exploring how the tiny, intricate pathways of your microcirculation influence everything from your energy levels and mental clarity to the simple comfort of warm extremities. Join us as we uncover this fascinating connection and look at how natural compounds, like those found in cayenne pepper, offer a glimpse into supporting this vital system. Age-related reduction in vascular elasticity. Vascular elasticity diminishes significantly with age. Arteries, which are typically flexible and capable of expanding and contracting to regulate blood flow, become stiffer. This stiffening process, known as arteriosclerosis, means blood vessels lose some of their ability to adapt to changing pressures and demands. Think of a healthy artery as a supple rubber hose. It can easily stretch to accommodate a surge of water and then recoil. An aging artery, however, becomes more like a rigid pipe, less able to expand and more prone to experiencing higher pressures. This reduced pliability affects how efficiently blood can be pumped throughout the body. The heart must work harder to push blood through these less yielding vessels, potentially leading to increased strain over time. This fundamental change in vascular structure underlies many age-related physiological shifts. The consequences of this decreased elasticity extend to the microcirculation, the network of the smallest blood vessels, including capillaries. These tiny vessels are crucial for delivering oxygen and nutrients to tissues and removing waste products. As larger arteries stiffen, the pressure changes transmitted to these delicate capillaries can become more pronounced. Furthermore, the walls of the microvessels themselves can also undergo changes, becoming less responsive to signals that regulate their diameter. This impaired ability of the microvasculature to adjust blood flow precisely where it's needed can result in localized areas of reduced perfusion. Consequently, tissues may not receive an optimal supply of oxygen, impacting their function. This reduction in microvascular responsiveness can manifest in various ways. For instance, the sensation of peripheral warmth is closely tied to adequate blood flow to the extremities. When microcirculation is compromised due to reduced vascular elasticity, blood may not reach the hands and feet as effectively, leading to a feeling of coldness even in moderate temperatures. Energy levels can also be affected. Tissues that are not efficiently supplied with oxygen and nutrients will struggle to produce energy, contributing to feelings of fatigue and reduced stamina. Brain clarity is another area susceptible to these changes. The brain is a metabolically active organ with a high demand for oxygen and glucose, and its function is exquisitely sensitive to blood flow. Impaired microcirculation can mean a less consistent supply of these vital resources, potentially impacting cognitive functions like focus and memory. Microcirculation versus major blood vessels. Major blood vessels, like arteries and veins, are the highways of our circulatory system, carrying blood in large volumes to and from vital organs. Think of them as the main thoroughfares of a city, facilitating rapid transport. However, the true work of nutrient and oxygen delivery, as well as waste removal at the cellular level, happens in the far more intricate network of microcirculation. This realm consists of arterioles, capillaries, and venules, tiny vessels, some no wider than a single red blood cell. It is here, within these microscopic channels, that the direct exchange of substances vital for cellular function occurs. As we age, particularly after 60, the efficiency of this microcirculatory network can diminish. This decline isn't always as dramatic as a major arterial blockage, but it profoundly impacts localized tissue health and function. Reduced blood flow in the capillaries can mean cells receive less oxygen and fewer nutrients. Simultaneously, the removal of metabolic byproducts becomes less efficient. This cellular-level compromise can manifest in various ways, affecting overall vitality and well-being. The difference is akin to a city's main roads remaining clear while the smaller residential streets become congested, hindering local deliveries and pickups. Consider the sensation of peripheral warmth. Adequate microcirculation ensures that blood reaches the extremities, such as fingers and toes, maintaining a comfortable temperature. When this microvascular network becomes less responsive, blood flow to these outer regions can decrease, leading to feelings of coldness. This is not a failure of the large arteries supplying the limbs, but rather a reduced capacity of the smallest vessels to perfuse the skin and subcutaneous tissues effectively. Similarly, the brain relies on a robust microcirculatory network to supply its vast number of neurons with constant oxygen and glucose. Impaired capillary function in the brain can contribute to feelings of fogginess or reduced mental acuity, as individual brain cells struggle to get the resources they need. Energy levels can also be affected. If muscle cells aren't receiving sufficient oxygen via capillaries, their ability to produce energy through aerobic metabolism is hampered. Why cold hands and feet increase after 60? As individuals age, particularly past the age of 60, a noticeable decrease in peripheral warmth, often manifesting as cold hands and feet, can become more common. This phenomenon is intrinsically linked to the gradual decline in the efficiency of microcirculation, the intricate network of tiny blood vessels responsible for delivering oxygen and nutrients to tissues throughout the body. With advancing age, these vessels can lose some of their natural elasticity and responsiveness. This reduced flexibility means they may not dilate as effectively in response to cooler temperatures or other stimuli that would normally promote blood flow. Consequently, the extremities, being furthest from the body's core, receive a diminished supply of warm blood, leading to that familiar sensation of coldness. The impact of compromised microcirculation extends beyond mere temperature regulation. Energy levels can be significantly affected. When blood flow is suboptimal, cells throughout the body, including muscle cells and those in vital organs, do not receive the consistent supply of oxygen and glucose they require for efficient energy production. This can translate into feelings of fatigue and a general lack of vitality, making everyday activities feel more demanding. Brain clarity is also a casualty of impaired microcirculation. The brain is an incredibly energy-hungry organ, and its optimal function is highly dependent on a steady stream of oxygenated blood. Reduced blood flow to the brain can impair cognitive processes, leading to difficulties with focus, memory, and overall mental acuity. Peripheral warmth is directly correlated with the volume and speed of blood flow reaching the extremities. The smaller arterioles and capillaries, which form the bulk of the microcirculation, are crucial for this localized delivery. Over time, changes in the endothelial lining of these vessels, along with potential reductions in nitric oxide production, a key molecule for vasodilation, can hinder their ability to widen and allow sufficient blood through. This reduced perfusion means less heat is transported to the hands and feet, making them more susceptible to feeling cold even in moderately warm environments. The body prioritizes blood flow to vital organs during temperature challenges, and in cases of reduced circulatory capacity, the extremities are often the first to experience reduced flow. The physiological changes that occur with aging, such as a slight stiffening of blood vessels and a potential decrease in the efficiency of the autonomic nervous system's regulation of blood flow, contribute to this decline. These factors can create a feedback loop where reduced warmth in the extremities signals the body to further restrict flow, exacerbating the problem. Understanding these interconnected processes, energy production, cognitive function, and peripheral temperature, highlights how fundamental microcirculatory health is to overall well-being, especially as we age. Oxygen delivery and cellular energy. As we age, the efficiency of oxygen delivery to our cells can gradually diminish. This process is fundamental to cellular energy production, a complex series of biochemical reactions that fuel every bodily function. Adenosine triphosphate, or ADP, is the primary energy currency of the cell, and its synthesis relies heavily on a consistent supply of oxygen. Impaired microcirculation, characterized by reduced blood flow in the smallest vessels, directly impacts this oxygenation. Consequently, cells may not receive enough oxygen to efficiently generate ATP, leading to a noticeable decrease in overall energy levels. This can manifest as fatigue and a general feeling of lethargy, making even simple daily activities feel more demanding. The impact extends beyond mere physical stamina. Cellular energy is crucial for maintaining optimal brain function. Neurons, in particular, are highly metabolically active and have a high demand for oxygen and glucose to perform tasks like thinking, memory recall, and concentration. When oxygen delivery is compromised due to microcirculatory issues, these cognitive processes can suffer. Brain fog, difficulty focusing, and slower processing speeds are often associated with reduced cellular energy in neural tissues. The brain requires a constant, robust supply of oxygenated blood to function at its peak. This intricate relationship between microcirculation, oxygen delivery, and cellular energy production is exemplified by botanical compounds that influence vascular function. For instance, capsaicin, the active compound in cayenne pepper, has been studied for its potential to support healthy blood flow. By interacting with specific receptors in the body, capsaicin may help to promote vasodilation, the widening of blood vessels. This vasodilation can, in turn, improve the passage of oxygen-rich blood through the microvasculature. Enhanced microcirculatory function means more efficient transport of oxygen to the cells, providing them with the essential ingredient for robust ATP synthesis. When cellular energy production is optimized through better oxygenation, the body's systems can operate more effectively. This includes the cells within the peripheral tissues, such as those in the extremities. Adequate blood flow ensures that these cells receive the oxygen and nutrients they need to maintain metabolic processes, contributing to a feeling of warmth and vitality. The cascade effect of improved microcirculation, leading to better cellular oxygenation and energy generation, can therefore have a widespread positive influence on a person's overall sense of well-being and physical capacity. Relationship between circulation and cognitive clarity. Reduced blood flow to the brain, a common consequence of declining microcirculation after age 60, can manifest as subtle shifts in cognitive function. The intricate network of tiny blood vessels in the brain is responsible for delivering vital oxygen and nutrients to neurons. As these vessels become less efficient, the brain's ability to perform at its peak can be compromised. This can translate into difficulties with focus and concentration. Tasks that once felt effortless might now require more mental exertion. Memory recall can also be affected. It's not necessarily about forgetting significant events, but more about the speed and ease with which information can be accessed. The brain's processing speed may slow down, making it harder to keep up with rapid conversations or complex problem-solving. The connection between a healthy circulatory system and sharp mental acuity is profound. Neurons rely on a constant, unimpeded supply of oxygen and glucose to function optimally. Impaired microcirculation means this supply line is disrupted. Think of it like a city's power grid experiencing brownouts. Essential services, including cognitive processes, become unreliable. This can lead to a feeling of mental fog. This fog isn't a sign of a serious neurological disorder, but rather a reflection of the brain not receiving the resources it needs to operate smoothly. Even minor reductions in blood flow can have a noticeable impact on cognitive performance, affecting everything from decision-making to the ability to learn new information. Peripheral warmth is another indicator often linked to effective microcirculation. When blood vessels throughout the body, including those in the extremities, are functioning well, they efficiently transport warm blood to all tissues. This ensures a comfortable body temperature, particularly in the hands and feet. In contrast, declining vascular function can lead to reduced blood flow to these outer regions. Consequently, individuals may experience persistent feelings of coldness in their hands and feet, even in otherwise warm environments. This sensation is a direct physiological response to diminished circulation, where the body prioritizes blood flow to vital organs, leaving the periphery less adequately supplied. This reduced flow can also contribute to a general feeling of lethargy, as the body's tissues are not receiving optimal nourishment and oxygenation. Capsaicin mechanism. Vasodilation support contextually explained. Capsaicin, the compound responsible for the heat in chili peppers, interacts with specific receptors in the body, notably TRPV1, transient receptor potential vanilloid 1 channels. These channels are found on sensory nerve endings and in vascular smooth muscle cells. When capsaicin binds to TRPV1, it initiates a cascade of events. Primarily, it triggers the release of neuropeptides, such as calcitonin gene-related peptide, CGRP. CGRP is a potent vasodilator. This means it signals the blood vessels to relax and widen. This relaxation of the vascular smooth muscle allows for increased blood flow. The vasodilation supported by capsaicin's action on TRPV1 channels is a key mechanism for improving microcirculation. The small blood vessels, the capillaries and arterioles, are where the exchange of oxygen, nutrients, and waste products occurs. By promoting relaxation in these tiny vessels, capsaicin can help to overcome some of the stiffening and reduced responsiveness that can occur with age. This improved flow through the microvasculature is crucial for delivering essential substances to tissues and removing metabolic byproducts efficiently. Consider the effect on peripheral warmth. When microcirculation is compromised, extremities often feel cold due to insufficient blood flow. By supporting vasodilation, capsaicin can contribute to a more robust circulation to the skin and extremities, potentially leading to a sensation of warmth. This is a direct consequence of increased blood volume reaching these areas. The body's ability to regulate temperature is closely linked to its circulatory system's efficiency. Furthermore, the enhanced blood flow facilitated by capsaicin's vasodilatory effects can have implications for brain clarity. Adequate oxygen and nutrient supply to brain cells is paramount for optimal cognitive function. When microcirculation in the brain is functioning well, neurotransmitter production and signaling can be more efficient. This supports processes like attention, memory, and overall mental acuity. The direct impact of improved blood flow on cellular health within the brain is a significant factor in maintaining cognitive performance. Historical culinary use of cayenne in different climates. Throughout history, indigenous populations across diverse geographical regions have incorporated cayenne pepper into their diets, a testament to its perceived benefits and culinary versatility. In warmer climates, such as those found in parts of India and Southeast Asia, the spice became a staple, often used to add heat to curries and stir-fries. This widespread use in regions where refrigeration was less common suggests a practical application beyond mere flavor enhancement. The inherent warming properties of capsaicin, the active compound in cayenne, may have been recognized as a way to promote circulation and a sense of internal warmth, particularly in humid environments where maintaining a stable body temperature could be a concern. Conversely, in cooler regions, cayenne found its way into traditional dishes as well, albeit perhaps with a different emphasis. Consider its presence in some European cuisines, particularly in areas with colder winters. While not as dominant as in tropical zones, its inclusion in stews, sauces, and even beverages points to a deliberate effort to introduce a warming element. This suggests an understanding, perhaps intuitive, that the spice could contribute to a feeling of internal heat and vitality, counteracting the effects of external cold. The widespread adoption across varied climates underscores a shared human experience of seeking out natural ways to influence bodily comfort and well-being through food. The culinary integration of cayenne pepper across these differing climates highlights a long-standing relationship between food, environment, and bodily sensation. From the vibrant, spicy dishes of the tropics to the heartier, warming meals of temperate zones, the spice has been a consistent ingredient. Its presence in such a broad spectrum of global cuisines, often in significant quantities, speaks to its enduring appeal and perceived efficacy as a culinary ingredient that extends beyond taste. Difference between stimulation and circulation support. Understanding the nuances between mere stimulation and genuine circulation support is crucial when considering the body's microvascular network, especially after the age of 60. Stimulation often refers to a transient, localized effect. Think of a fleeting tingle or a brief flush of heat. This might be achieved through intense physical activity that temporarily increases blood flow to working muscles or through certain topical agents that trigger nerve endings. Such responses, while noticeable, don't necessarily translate to sustained improvements in the health or function of the small blood vessels themselves. They're more akin to a short-term jolt, a quick surge that fades as the stimulus is removed. Circulation support, conversely, aims for a deeper, more enduring impact on the vascular system. It involves fostering an environment where microvessels can operate efficiently, delivering vital oxygen and nutrients to tissues and removing metabolic waste. This goes beyond a temporary increase in flow. It's about enhancing the flexibility of vessel walls, reducing inflammation, and improving the overall permeability of the capillary network. For instance, regular moderate exercise, a balanced diet rich in antioxidants, and certain botanical compounds work by influencing endothelial function, the lining of blood vessels, promoting their long-term health and responsiveness. Consider cayenne pepper, a common culinary spice. Its primary active compound, capsaicin, is often associated with a sensation of heat and tingling when consumed or applied topically. This is a form of stimulation. Capsaicin interacts with transient receptor potential vanilloid 1, TRPV1, channels, which are involved in sensing heat and pain, leading to that characteristic warming sensation and a temporary dilation of superficial blood vessels. This immediate effect can contribute to a feeling of increased blood flow to the skin, making extremities feel warmer for a short period. However, the impact of capsaicin can extend beyond mere immediate stimulation to offer a degree of circulation support. Research suggests that regular, moderate intake of capsaicin may influence factors contributing to vascular health. It has been observed to play a role in supporting healthy blood pressure levels and potentially improving endothelial function over time. This suggests a mechanism that goes beyond a simple, fleeting dilation, hinting at a more profound influence on the underlying health and operational capacity of the circulatory system, particularly at the microcirculatory level, which is vital for nutrient delivery and waste removal throughout the body. Safety considerations without dosage instructions. As individuals age, particularly after the age of 60, functional vascular decline can manifest in subtle yet impactful ways. This decline is intricately linked to changes in microcirculation, the body's network of tiny blood vessels, capillaries, and venules. Impaired microcirculation can restrict the efficient delivery of oxygen and nutrients to tissues, directly influencing how energetic a person feels. Reduced blood flow means cells have less fuel for their metabolic processes, potentially leading to feelings of fatigue or a general lack of vitality. This generalized reduction in cellular energy production is a common experience, not specific to any one condition. Furthermore, the clarity of thought and cognitive function are also susceptible to microcirculatory changes. The brain, being a highly metabolically active organ, relies heavily on a consistent and robust blood supply. When microcirculation falters, the brain may not receive adequate oxygen, impacting neuronal function. This can translate into difficulties with focus, memory recall, or processing speed. Peripheral warmth, the sensation of comfortable temperature in the extremities like hands and feet, is another indicator. Reduced blood flow to these areas, often a consequence of microcirculatory compromise, can lead to a persistent feeling of coldness, even in otherwise warm environments. Botanical substances can interact with the body's vascular system. For instance, cayenne pepper, known for its active compound capsaicin, has been observed to influence blood flow. Capsaicin can trigger a temporary increase in circulation by stimulating the release of certain compounds that widen blood vessels. This localized effect can contribute to a transient feeling of warmth and potentially enhance nutrient delivery to the immediate area. However, it is crucial to acknowledge that such botanical interventions, while potentially supportive, come with their own set of considerations. When considering any botanical agent, including cayenne pepper, it is essential to approach its use with awareness and caution. Individuals with pre-existing health conditions, particularly those affecting the cardiovascular system or gastrointestinal tract, should exercise prudence. Certain sensitivities or adverse reactions are possible. It is always advisable to consult with a healthcare professional before incorporating any new substance into one's routine, especially if taking other medications or if you have specific health concerns. This ensures a safe and informed approach to personal well-being. As we age, the subtle changes in our microcirculation can impact our daily vitality. Understanding how these tiny vessels influence energy levels, mental sharpness, and even the warmth in our extremities provides valuable insight into maintaining our well-being. Exploring natural botanical allies, like the capsaicin found in cayenne pepper, offers a way to support these vital functions. It's a reminder that small, consistent efforts can contribute to a more vibrant life. We hope this exploration has sparked your curiosity about the remarkable power of our circulatory system. In our next video, we'll delve deeper into the fascinating world of cellular repair, examining how our bodies naturally work to maintain and regenerate tissues.